All right, so when do quadratic equations come up in applications? So the two examples that I'm going to do is geometric applications. I just want to review the solving applied problems by translating to algebra. So again, the steps we'll be asking ourselves through all, it'd be like, what are you looking for? Understand the question asked, list all the quantities. Step two, how are these quantities related to each other? So we'll come up with expressions relating those quantities. And then step three, what mathematical process involves all the quantities. And what's nice about geometric problems is that known formulas will be used to come up with these relationships and how the quantities are being used in a mathematical process. All right, so just going to the first example. Again, this is a geometric problem, so it says a rectangle has an area of 55 square meters, so I'm just going to put that inside. Its length is 1 meter more than twice its width. Find the dimensions of the rectangle. So I actually need to define the width and the length, and I'm just going to use this diagram to help me with it. And using the relationship that its length is 1 meter more than twice the width. So if I let the width equal x, representing the width, then I know the length is 1 meter more than twice x, or 2x plus 1. So the next step is, what formula do I need? Well, I know the area of a triangle is the length times the width, or the width times the length. It really doesn't matter. So I'm just going to use this formula and plug in the information for my rectangle. So the area, which is 55, is equal to the length, which is 2x plus 1, times the width, which is represented by x. So if we want to solve this problem, we want to expand everything. So we're going to 55 equals, we'll just distribute the x through, we get 2x squared plus x. And then setting it equal to 0, we'll subtract 55 from both sides. And we get 0 equals 2x squared plus x minus 55. This quadratic does factor, and the factors are 2x and x. It will factor into binomials. It ends up being 2x plus 11 and 2x minus 5. So that's equal to 0. So by the zero factor property, we just take each of these factors, 2x plus 11, set that equal to 0, or the other factor, x minus 5, equals 0. So now we'll go ahead and solve each one of these. And if you notice the one on the left, the 2x plus 11, if I subtract 11, I get 2x equals negative 11. And then canceling the 2, I get x equals negative 11 halves. Or on the right, x minus 5 equals 0. If I just add 5 to both sides, I get x equals 5. Now, in terms of our answer, I'm looking for the width of the rectangle, so negative values won't work for this application, so we get rid of it. So we do get one answer, x equals 5, and x is a width, so we know that the width is 5 meters, and to find the length, we just plug 5 in to our expression for the length. That would be 2 times 5 plus 1, or 10 plus 1, which is 11. So in our answer, we know the length then is 11 meters. All right, so the next application is talking about a triangle, and it says the height of a triangle sail, and this is a right triangle, is 4 yards more than twice the length of the base. If the sail has an area of 15 square yards, find the base and the height. So again, I'm looking for the base, which is represented by the bottom length, and the height is represented by this side. So again, I want to define both of these, and it says the height is 4 yards more than twice the width or the length of the base, sorry. So if we let the length of the base equal x, then the height is 4 yards more than twice that. So 4 yards more than twice x would be 2x plus 4. So I know the area is given to me, so I want to use the area formula for the triangle. So the area of a triangle is 1/2 times the base times the height. So again, I'm just going to plug in the information. I know the area is 15 yards, and that's equal 1/2. The base is x, so that's 1/2 times x, and the height is 2x plus 4. All right, so simplifying the right side, we notice that the 1/2 x is the same as x over 2. And then I'm going to multiply that by 2x plus 4. So when I distribute, I'm going to end up with x plus 2 times 2x, and then an x plus 2 times 4. And when I do this, I can just use canceling. So the 2's cancel, leaving just x squared. So this would equal x squared. And on this side, the 2 and the 4 would cancel, leaving a factor of 2. So this would be a term of plus 2x. And that equals 15. So we get our quadratic equation, and I'm just going to subtract 15 from both sides to get it equal to 0. So I get 0 equals x squared plus 2x minus 15. So I'm just scrolling up a little bit so I can see it. So we're going to solve this by factoring, and it does factor. This would factor to an x plus 5 times an x minus 3. That's equal to 0. So to solve this, we set each factor equal to 0. So we get x equals negative 5 or x equals 3. Well, of course, again, we're looking for the length of the base and the height. So a negative value will not work for this application. So x equal to 3 is giving us the length of the base. So we know that the base has length 3, and this is in terms of yards. And the height is, and we just need to plug 3 in to the 2x plus 4. And if I do that, I get 2 times 3 plus 4, or 6 plus 4, which is 10. So the height is 10 yards.